Good morning, students. Today we are going to read about excitation table of flip-flop. What is the excitation table? Excitation table is looking at truth table in the reverse way. What the meaning of this excitation table? The content of excitation table is like that present state that is represented by Qn and the next state is represented by Qn plus 1. Already we are familiar these terms and the required input that is S and R. So the present state and the next state, two variables and have the four combination 0 to 0 transition, 0 to 1 transition and 1 to 0 transition and 1 to 1 transition. For all these value, we find the value of excitations, that is input of flip-flop, that is SR in case of SR flip-flop, JK in case of JK flip-flop, T input in case of T flip-flop and D input in case of D flip-flop. Okay, here we are find the excitation table for SR flip-flop. So the content of excitation table is always same as shown in Qn plus 1 and the required inputs. Okay, let's start. For excitation table, we write the truth table for particular flip-flop. Here we calculate or we find the excitation table of SR flip-flop. So we need to write truth table of SR flip-flop. So write here SR, that is input of flip-flop, and the output, that is the next state Qn plus 1. We know that as truth table of the SR flip-flop, it is memorized 0 to 0. When value of SR is 0, 0, the flip-flop is constant in present state, that is Qn or no change. When S equal to 0 or R equal to 1 means flip-flop is reset condition. It means Qn plus means reset output will be reset, that is 0. In case of 1 and 0, set equal to 1. In case flip-flop is the state is set, that is 1. And in case of 1, 1, it is forbidden or invalid condition for this flip-flop. Using the truth table, we are design the characteristic table. We are familiar also this characteristic table. Its content S, R, Qn and Qn plus 1. Because Qn is the present state of any flip-flop, may be set or reset, that is 1 and 0. So for each combination we have the two present state. For this combination Qn will be 0 and 1. For this combination Qn will be 0 and 1. Also for this and also for this. So in the characteristic table is extended of truth table, that is 4 rows here as 8 rows because Qn have the true value for particular flip-flop. So 0 to 0, in case of 0 to 0, Qn is 0 if then output is 0. In case of 0 to 0 but Qn is 1, here is present state 1, so our next state is 1. Okay, next is 0 1 0 1 case. For 0 1 case and the Qn is 0, that is flip-flop is reset, the output is reset because reset as R equal to 1, so output is 0 always. This condition 0 1 but Qn is 1, but we look the condition of reset, that is 1, so output is 0. Again we saw the set and reset. Set equal to 1 and R equal to 0 and Qn, that is the reset condition, output is according to set, so it means 1, it also 1. And for the next combination in which S and R both are equivalent to 1, either Qn will be 0 or 1, the output always will be invalid or forbidden state. Okay. For the process, the design of excitation table, we read 4 transition. For the excitation table is contain Qn and Qn plus 1, that is present state and the next state. 0 to 0 transition. Okay, for 0 to 0 transition, we look the characteristic table here. 0 to 0, that is a Qn and that is Qn plus 1. So, see here 0 to 0 and find out the other same match, that is Qn is 0 and Qn plus 1, that is the next state is will be 0. Here we see that two combination are there. Okay, these combinations have the SR value. We can see S equal to 0 for both conditions, and R, it is 0 and it is 1. We can see S have the value is 0 but R have the 0 and 1, means S have the fixed value, that is 0 of the excitation table. So we can write here 0 and R equal to 0 or 1, that is that don't care. I don't know what is the fixed value of R. So we can write here that is the don't care. Okay, students, next for transition we can write 0 to 1 transition. So we can find the value of S and R for the excitation table. So we go through the characteristic table, that is 0 to 1. Find the 0 to 1 here. This is the 0 to 1. 0 to 1 and no other combination is present. Okay, so write here 0 to 1, S equivalent to 1 and R equivalent to 0. So write is S equal to 1 and R equal to 0 in the excitation tables required input. Next transition in 1 to 0. 1 to 0. Right, find out the Qn is 1 to 0, this one 1 to 0 is present and another 1 to 0, no. Okay, 1 to 0, so means S equal to 0 and R equal to 1. So write here in the excitation table is S equal to 0 and R equal to 1. And 1 to 1 transition. So find out to 1 to 1 transition in the characteristic table for Q and Qn plus 1 to 1 transition here is present here and again it is present here. So we can find the value of S and R. See, R equal to 0 in both condition and S equal to 0 and 1. So write here S equal to don't care and R equal to fixed, that is value 0. So we can say SR for the excitation table is don't care and 0. Now we can put the value of S and R from the 4 transition. 0 to 0, we find the value of 0 to 0 as in 0 to 0 transition. We find the value S and R value 0 and don't care. So write here 0 and don't care. For the next transition, that is the 0 to 1, we have the value S R equivalent to 1 and 0. So write here 1 and 0. Next transition is 1 to 0. For 1 to 0, we have the S and R value 0 and 1. So write here 0 and 1. And next transition in 1 to 1. For 1 to 1 transition, we have value S and R, that is don't care and 0. So write here don't care and 0. In this way, we can design any excitation table for any flip-flop. This is the excitation table of SR flip-flop. Okay, move to excitation table for JK flip-flop. Similarly, JK flip-flop excitation table contains Qn plus 1 and the required input. In this case, required input is J and K. So we write first two table of JK flip-flop and then write the characteristic table of JK flip-flop, and from the characteristic tables transition 0 to 0, 0 to 1, 1 to 0 and 1 to 1, that is the present state to next state transition, and find the value of required input, that is J and K. A similar process in the RS flip-flop. Right here J and K, and that is the output state. 0 to 0, we know all familiar and we know that 0 to 0 for JK flip-flop output is always present state, that is no change. 0 to 1, because K is similar to reset, so the output is reset condition, that is 0. And here 1 and 0, J is represented to as, that is set, so output will be 1 to 0 for 1. And in case of 1 to 1, here is toggling process. Toggling condition is when J and K both are 1, the output always toggle to present state. If present state 0, the output or next state to 1. If 1, then output state to 0. Okay, using this truth table, we can draw the characteristic table. Using the QN condition, it may be 0 or 1. That is present condition or flip-flop of any present condition, it should be 1 or it may be 0. So write here 2 combination for 0, 0, 2 combination for 0, 1, 2 combination for 1, 0 and 2 combination 1 to 1. Write here according to Qn and the set and reset condition, we find the value of Qn plus 1. Okay. For the excitation table, we require the inputs, that is the J and K for the Qn and Qn plus 1, that is the present state and that is the next state. Present state is combination transition is 0 to 0. For 0 to 0, we find the combination, 1 combination present and 2 combination is present. So see here, 0, J is 0 for both condition, but K is 0 and 1. So we can say J is fixed, that is 0, and K is down here, that is X. So write here for 0 to 0 transition is 0, J is 0 and K is don't care. Next transition is 0 to 1. 0 to 1, so we find the Qn is 0 to 1. See here 0 to 1 is 1 and next is 0 to 1 is also 1. So in this case J is 1 and K is don't care. So write here J is 1 and K is don't care. Next transition in 1 to 0. So find out the 1 to 0, this 1 to 0 is 1 combination is there, also 1 to 0 is again is here. So we find that K is 1 but J is don't care. So write here J is don't care and K is 1. And last transition is 1 to 1. For 1 to 1 transition, we find out the 1 combination is there, 1 to 1 combination and also 1 to 1 combination. In this case, we find the value of J is don't care and K is 0, that is fixed. Okay. So excitation table, we can draw the excitation table or fill the value of required input, that is J and K. Okay. For 0 to 0, J and K is 0 and don't care. For next combination, that is the 0 to 1. 0 to 1, so it is 1 and don't care. 1 to 0 is don't care and 1, and last one is 1 to 1 and don't care and 0. In this process, we find the excitation table of D flip-flop and also T flip-flops. Same process, write the truth table, write the characteristic table and write the excitation table of both flip-flop as well as T flip-flop and as well as D flip-flop, that is the T and D flip-flop. The excitation table is very important from the point of your exams. When exams, in the RTO exams papers, you may see number of questions in many years asking from the excitation table. So dear students must go through excitation table of all the flip-flop. Process is similar, but you must remember the truth table firstly, and then design the character and the way the design of characteristic table and the excitation tables. Okay, best of luck and thank you.